Testing. Audio test.
Belleville, this is Houston. Can you hear me?
Audio test.
Belleville, this is Houston. Can you hear me?
Yes, we can hear you.
Great, I can hear you too. I just wanted to let you know that your comm will end at 9:49 Central. You have a slight gap in comm, and you need to be finished with your conference by 9:55 Central. And we will let Sandy know that you're ready for her.
Hello, Belleville West. Let's give a mighty maroon welcome to class of 1982 graduate Dr. Sandra Magnus, who is with us today as she orbits in the space station live. On behalf of Bob Dahm, I'd like to welcome Millstock Grade School, along with retired superintendent Dr. Robert Dozier and retired physics instructor Mr. Gary Shupek. Dr. Magnus, it's great to see you. This is Joe Lombardi. I'm the science department chair here at Belleville West. Hello, Dr. Magnus. This is Joe Lombardi from Belleville West.
Morning, how do you hear me?
We can hear you great.
A video as well.
Yes, excellent. Everything's going great.
Very good. So you guys can see me, right?
Yes. And it looks like by your T-shirt.
Okay, very good. I guess we can get started.
It looks like by your T-shirt.
Yeah, I brought a couple things with me from Belleville West. I brought this T-shirt, and the science classes will probably recognize the Einstein mole. I was able to bring it. I had to take it off of its stand, though. So it made the trip with me.
Well, it looks like once you're a maroon, you're always a maroon, huh?
Absolutely correct.
I'll be passing the microphone to our first student for the questioning.
Hello, my name is Nisi.
Very good.
Yeah, I asked what made you decide to be an astronaut. With this being said, what hard work came along with the decision that you made?
Yeah, you know, I was about junior high age when I decided to be an astronaut, and I don't really have a good reason. I wanted to explore. I really liked math and science. I thought it'd be really neat to be on the edge of technology and doing something really challenging like that. So I decided space exploration was for me. And, you know, it was a lot of hard work, but it was fun, too, because I enjoyed math and science so much. It wasn't really like hard work. It was more like a way to expand my curiosity and learn a bunch of new things. And that's one of the fun things about this job is I'm always learning something new.
Hi, my name is Randy Merriman, and my question is, what's a typical day like on the space station?
We're on Greenwich Mean Time, so I get up about midnight Belleville time. It's about 6 o'clock in the morning Greenwich Mean Time, and we have a couple hours to get ourselves organized, and then the work starts. We get plans from the ground every day of what our tasks are, and we take a break for lunch, usually around 1 o'clock our time, and then we work till about 6 o'clock in the evening. We have a planning conference at the ground to discuss the next day. We have a couple hours to have dinner, wind down, take care of some email and phone calling home and things like that, and then we're supposed to go to bed around 9:30, but that's way too early, so I usually don't go to bed until about 11 or so, and that's sort of a typical day.
Hi, I'm Kristen Langston. I'm a junior, and as a mission specialist, what do you do exactly?
You know, in our office, the mission specialist designation was created to separate us from the pilots, who are people who've come out of the military and are test pilots because they fly the shuttle. Here on Space Station, that designation is not as important. But as a mission specialist, I'm in charge of doing the science, any kind of repairs that need to be done, if there's a spacewalk or robotics or anything like that. Those are typical tasks that have fallen to mission specialists in the past. So we get a lot of training to cover all of that stuff.
This is Gary Shupek. Sandra, I'm asking a question for Kevin Johnson, Sr., When doing work on the International Space Station, is there a substantial language barrier, and do the cosmonauts speak English?
You know, it's a good question because it's an international space station. We work with people from Japan, with people from all over Europe, Canada, Russia, of course, and the U.S. And what we do is the main two control centers are in Russia and in Houston there. And we talk Russian to the Russians in Moscow, and we speak English to the people over here in Houston. So we learn Russian, and the cosmonauts learn English. And the Japanese and the Europeans and the Canadians, bless their hearts, they learn both. So we're actually quite lucky. English is sort of the main language, and Russian is also a very strong main language. So we spend a lot of time learning each other's languages, and that's a lot of fun, too.
Hi, Dr. Magnus. My name is Jackie Bossler, and I'm a junior. And I was wondering, what is it like being a female astronaut in a male-dominated profession?
Well, you know, it's interesting because the most important thing about being an astronaut is really not whether you're a male or a female or from the military or not from the military or a doctor or engineer. It's can you do the job? Do you have the skills? Do you have the enthusiasm? Do you have the dedication? Can people depend on you with their lives, for example? And these are the things that are important. So we're really not judged on male or female or backgrounds. We're judged on, are you dependable? Can people count on you? Do you do your job kinds of things? So it doesn't really have that kind of a feel to it, if you know what I mean.
Okay. Hi, Dr. Magnus. I'm Brandon Bernhardt, and my question is, when you come back from Earth, how long does it take for you to feel normal since you were in zero gravity so long? And do you need to do anything special so you don't get sick when you come back from space?
Well, after my first mission, it was only 11 days, and it was so short that there's really not anything that you have to do special. I did not feel sick after my first mission. Some people do. I was very wobbly on my feet. It took me 3 days or so to stand up and not feel like I was going to fall over. And I also had a little bit of orthostatic intolerance. It's when you stand up real fast and you kind of see brown spots before your eyes and you can fall over. So this time, being here for 4 months, first of all, we're required to exercise 2 hours a day. Part of that is cardio. We get on a bicycle ergometer or on a treadmill with these big bands, strong rubber bands that hold us down to provide some loading on our bodies. And the other hour, the other part of the exercise is resistive exercise, and it kind of simulates weightlifting, so we can load, again, it's with some bungees and things like that, so we can load the bones in our hips and our legs to simulate gravity. And by doing that, we minimize the calcium loss from our bones, we keep our muscles strong, and we're in better shape to come back to Earth. However, I've been told by some of my colleagues that I'll probably have some back pain. My neck will probably hurt from holding up my head. You know, our heads are actually quite heavy, and I'll be very tired. My calves may be tight. So I'm interested to see the difference between the short duration of only 11 days and this time about 4 months.
Hi, Dr. Magnus. This is Cameron Kuvian, a freshman here at West. My question is, how often do you have to exercise to maintain muscle strength and bone density in the zero-gravity conditions of space?
Yeah, and you're exactly right. We do need to do that. I get 2 hours a day scheduled, and I typically spend about 45 minutes on the bike when I ride it. I run on the treadmill for 3 or 4 miles, and I do resistive exercise for a little bit less than an hour, and I include stretching, which is also very important.
Hi, Dr. Magnus. This is Ben Christensen, a junior at Belleville West. What kind of experiments has NASA been conducting lately? Have you taken part in any of them? And what purpose did the experiments serve?
Well, not only does NASA have experiments up here, but Japan and all of Europe and Russia has experiments, and they're all collaborative, so we're all trying to build off of each other's experience. It's funny that you ask about which experiments I'm participating in, because you know I am a human guinea pig up here, and there are several different kinds of medical experiments they even do on us. And so there's things where they study our nutrition, because we're trying to work on the biochemistry involved and the changes involved, so they're studying nutrition levels in us. Our immune system gets deficient. We've got some fluid physics experiments going on from Europe, Japan, and the U.S. In the past, we've done some plant studies. We've got some crystallization studies. There's even some combustion studies going on. They're all very interesting, and they all take advantage of the unique environment we have up here with microgravity.
This is Abby Herzing, a junior here at West, and I was wondering if you had the chance to be the first person to go to Mars but had to spend 20 years of your life doing it, would you?
You know, Abby, I looked at your question and that made me really think hard, because you think about 20 years of your life training or preparing to do something, and that's a significant portion. And then I realized that when I first wanted to be an astronaut, I was in 7th or 8th grade, and I finally got into the astronaut corps when I was 31, and I finally flew in space for the first time when I was 36. And so you look at that, and that was almost 20 years of my life just to fly in space for the first time. And here I am 6 years after my first trip doing my second trip. So, yeah, I think it is worth 20 years to prepare for something you really want to do. And like I said before, if it's something you really want to do, it's not really hard work. Fun, because you're challenging yourself and you're learning new things and you're having interesting experiences along the way. So, yeah, it's worth it.
Hi, Dr. Magnus. This is Amanda Linder. I'm a junior here at West. And if you could have one thing from your home with you in space, what would it be?
That's another good question. I started to think about what I miss the most. And you know, it's funny because I miss my kitchen because I like to cook. And I've been trying to cook here a little bit, but it's really hard with things floating away all the time. You can't just put something in a mixing bowl and have it sit there and mix. I've been using Ziploc bags to try and mix stuff into, and I had tuna flying all over the place the other day. And so I think if I could bring something I really missed, it would be some kind of cooking utensil so I could create new foods up here.
Hi, Dr. Magnus. This is Nicholas Dintelman. I'm a junior at West, and I was wondering if you could tell us about the water recovery systems that you recently installed and what they do to recycle water up in space.
Hello, Nicholas. You'll have to tell your father hello for me. We were high school classmates there at West. The water system that we just installed is very important because up till now we've been getting water deliveries, major water deliveries from the shuttle, and we haven't had a closed-loop recycling system up here. With this system that we've just installed, now we can take condensate water and urine, and we can recycle this and create a closed-loop system so that we're constantly replenishing, refreshing, and reusing our water. This is actually very important because the shuttles, as you know, are going to retire in 2010, and we're not going to be able to get these strong deliveries of water. This will be useful technology as well once we demonstrate that it works well here in the space station, that we can use it when we go to the moon and when we go to Mars someday. So it's both an enhancement of the station and technology development for future space flights.
Hi, Dr. Magnus. This is China Bird. I'm a junior. My question is, what is it like spending the Christmas season away from your family and friends and not getting to share in the joy of the holiday season?
Well, there's a couple of things there. Number one, I think I'll get to share in the joys of the holiday season with my family. It'll just be done a little bit long distance because I'll be on a video conference with them, and I'll be able to look out the window and sort of think about the earth and you know, life and what Christmas really means. So I think I'll be able to share in the joy. However, I am going to miss my family. I do miss my family. I miss my friends. I'm very lucky in that I have a phone and I can call them. When we have the red antenna hooks up and we have email, and I get to do video conferences once a week. So I do stay in touch. It's, you know, you always have sacrifices when you do something, and that's a little bit of a sacrifice that I'm making for this program.
Hi, I'm Amanda Foppy. I'm a sophomore. Do you have to strap yourself down when you go to sleep so you don't float around?
Actually, Amanda, that's a really good question because that was one of the things I found the most difficult when I first got here was sleeping. You're used to laying on your bed and feeling gravity holding you down, and here you float, and so it does help strap yourself down a little bit so you have at least the feeling that you're leaning against something. It's not the same firm kind of feeling you have from laying in bed, but I have a bungee cord around my sleeping bag, and that sort of makes me feel confined a little bit, and it helps me to sleep.
Hi, my name's John Zimmer. I'm a freshman. How do they keep micrometeorites from penetrating the outer hull of the space station?
And that is definitely a concern because if we get a big micrometeorite hit the station and penetrate the hull, then we have a depressurization event, which is something you don't want to deal with. They put shields. There's a couple different ways you can do it. What NASA's chosen to do is they put aluminum shields around the outside of the station in the more vulnerable areas, and what that does is that slows down the micrometeorites and disperses their energy, so by the time that they would penetrate those shields and hit the hull, they wouldn't be a problem. There was a really interesting technology that people were looking at use water as a way, a multi-layer system and then water and then a multi-layer system as kind of a whole concept to mitigate some of the micrometeorite problems. And at the same time, you're using that as your water storage tank, and at the same time, water is actually a very effective radiation shield as well. So there's a couple of unique ideas out there for micrometeorite protection.
Hi, Dr. Magnus. My name is Kyle Wallen, and I'm a freshman. And my question is, in light of the fact that microgravity affects body processes, how does it affect your digestive system?
And that's a really good question, and luckily it doesn't affect very much our digestive system. Our digestive system apparently works off of muscles, and so we can eat pretty much normally and function pretty much normally, so thank goodness. So we're pretty good there. It does affect our hearts a little bit, and so we have a little bit of a cardio deterioration, which we slowly build back up with our exercise, but our digestive system works fine.
Hello, my name is Amanda Riza, and I'm a freshman. What is your favorite thing that you can do in space but you can't do on Earth?
What is my favorite thing to do in space that I can't do on Earth? Gosh, float, look out the window. Some of these things that are a lot of fun to do are also make life difficult, though. Sometimes, like I said, things don't stay put when you put them down. They tend to float off, so you need Velcro or tape, or as a matter of fact, there goes a little Einstein mole floating off. And so you have to really work carefully and slowly.
Hi, Dr. Magnus. This is Chelsea Burkle, and I'm a senior. There are so many things that could go wrong in space. Do these various possibilities worry you, and do you believe that the experience makes it worth the risks?
And Belleville West, this is the space station. Can you still copy?
Yes, copy.
And Belleville West is International Space Station. Do you copy?
Yes, copy.
Okay, go ahead with your next question.
Hi, this is Claire Bierman. I'm a junior. What is the best rationale in support of continuing the construction and expansion of the International Space Station?
There's a lot of things that we get from the space station. Number one, the benefit of doing the science up here in space. Number two, it's a good technology demonstration for developing equipment and hardware and things that we need to go to the moon and Mars. I think a big intangible benefit that we get that no one even it's not obvious, no one thinks about, is the fact that you've got all these countries all over the world. There's 16 or 17 countries involved, and it's different languages like we discussed earlier. There's different cultures, different ways of doing engineering, different ways of approaching problems, and we're all working together, and we created this big, huge house, laboratory, living space in the sky, and it's all these people around the world who are now connected, and I think it's going to help us as human beings learn to work together more and more and more in the future, and I think that's a huge intangible benefit that we're getting from the space station right there.
Hi, Dr. Magnus. My name is Emma Magner, and I'm a senior at West. And my question is, has going up in space changed your perception or attitude about life on Earth?
You know, one of the most interesting things I noticed right away on my first mission when I looked out the shuttle window as we were opening the payload bay doors is I looked down at the Earth and I saw how incredibly thin our atmosphere is. And you don't think about it because it's just there all the time. But think about driving, putting a string on your car and driving from Belleville to Springfield, Illinois. And you take that string and you go straight up. And that's about where I am. And I'm well out of the atmosphere. And so we have this very thin sheet of air on our planet that's keeping us all alive, and it really struck me how fragile our planet is and how much we have to take care of it. That made a huge impact on me.
Hi, Dr. Magnus. This is Kendra Jones, and I'm a junior at West. What benefit would the work you're doing in space have for us on Earth, both now and in the future?
Well, of course, we're doing a lot of experiments up here that just by nature of creating the equipment and creating the technology to be here, we're helping a lot of people on the Earth. A lot of the portable medical equipment came out of the space program. Some of the medical data they gather on us is going to help people with osteoporosis and other types of illnesses. So any kind of research or any kind of technology development we do here immediately spills back into societies all over the planet. But I think also we human beings need to explore. We need to ask why. We have a natural curiosity, and this is an embodiment of that spirit, and that just feeds back into people and how they live and how they look at the world, and I think that's very important.
Hi, Dr. Magnus. This is Grant Gonzalez, and I'm a junior. What is your favorite sight to see in space? The Earth, the stars, or the moon?
Well, you know, they're all beautiful, but we've been very lucky in that we've had a really bright, full, beautiful moon while I've been here, and you can see Venus and Jupiter just past the moon over the Earth's horizon, so it's been very special. But I have to tell you, my favorite thing to look at on the Earth are the islands in the middle of the ocean, where they have the coral reefs, so there's the peaks of undersea volcanoes poking up out of the water, because you can see very clearly the color of the water change from the deep, dark blues of the ocean to the aquamarines and the greens and the light blues of the shallower waters around the reef. It's just beautiful. I've been taking tons of pictures of these areas, and film unfortunately can't capture all of the beauty, but I'm hoping to get a few good pictures out of it.
Hi, I'm Heather Dom. I'm a senior at West. What's your favorite memory in space?
Wow, I think my favorite memory, there's so many good memories of being here, but I think one of my favorite memories is when I was arriving, as we're rendezvousing and docking with the shuttle. You see the station from far off, and it looks like this bright little star. And as you get closer and closer, it keeps getting bigger and bigger and bigger. And you approach the station, and you look at this huge monster building that we've built in space, that we human beings as a species have accomplished this incredibly complex construction project across all nations, all languages. And here is the proof of what working together can do. And it was just very special to see this space station flying above the Earth like that and knowing that I get to spend some time there. That's probably the most memorable moment that I've had.
Dr. Magnus, this is Joe Lombardi. That was our last question, and I just wanted to say thank you on behalf of Belleville West for all that you've done in this experience. You are a true testament to courage and character, and thank you for showing us all these wonderful things that you've done for us. You are a true experience, you're a true example of what a Mighty Maroon can do, and there's no limits to that. So thank you again.
It's been my pleasure, and I would only echo what said. There are no limits. Don't put limits on yourself. Anything is possible. You guys can achieve anything you put your mind to. It's not hard work. It's fun, and I want you all to just do that. Find your dream and follow it. I hope you enjoyed today. I enjoyed myself as well, and I'll see you guys in Belleville when I get back. Bye-bye.